Hello and welcome to a second video about my home lab. In the first video, many people asked, what do you use that for? And why did you build it? And how much power does it use? And so we'll talk about that a little bit. As far as why did I build it? I built it because I was building a new house and I wanted to have a data environment I could run stuff in. Probably most of all, I wanted a place I could both learn in building it, in designing the power system, and doing the wiring. I did a lot of fiber in the house, and so I ended up getting a fusion splicer and learning a little bit about being able to splice fiber and things of that nature, patch down cables, that kind of stuff. Designing the rack environment, the cooling system, both air conditioner cooling and then some economizers. And so the idea of building it itself was a really cool idea and something that I could learn a great deal from as I went along the way. Once I sort of had it built, then it's a question of, well, what do you use it for? And it is a home lab. So the reason you build one and have one is so that you can continuously be learning new things. You can install new technologies and try them out. And it doesn't have to be a home lab nearly this big. You can just have a small NUC running Proxmox with VMs, and you can use that to learn a lot of things. In my case, what I actually use those computers for, there are some things that are sort of more house related. Things like Grafana influx Telegram, so house monitoring. I have CT couplings on every single circuit in the house so I can monitor them all. There's of course a Plex server for video stuff. HomeSeer and Home Assistant for home automation, a couple other database servers for some different things, Blue Iris for video camera recording, a couple of AI things related, one language model for interpreting text, another one for watching video. And those are pretty typical kind of home automation related things. And those things I kind of want to be reliable and work all the time. So they're running on a Proxmox cluster with Ceph, and so that's multi-node and HA. And that kind of guarantees that they generally are running all the time. That is a small portion of that entire set of equipment in there. Probably the single biggest overall component is just storage, and there's about a petabyte of storage total. Within that petabyte, a lot of it are backup copies of things. I think maybe I have somewhere between 150 and 200 terabytes of stuff that I would call important that I want to keep. I have a primary file server that uses ZFS, and that ZFS server actually has basically a duplicate set of disks. So there's two complete ZFS arrays, one of which is just a backup of the first one. And the first one I actively use for all kinds of different projects. And then I have a backup server that turns on every Sunday, so it powers on, does a full diff backup of all the servers and some VMs onto disk, and then powers back off. And then once a month, that server also fires up a job to do an LTO tape backup to a set of tapes that I keep sort of not here in the house. And then actually there's another job that fires every week too and diffs a subsection of it to a file server that I have in a cabinet at a data center here in Portland, sort of for another offsite backup. And so that's really just around keeping that data from getting lost. A lot of it's personal data. I have every email I've sent since I was in college in 1994, every utility bill I've ever paid, a bunch of cool sort of data stuff like that. Lots of project data, things that I built, code that I've written, hardware that I've designed, stuff like that. And then I do a lot of vintage computing, which you probably can't see, but there's a bunch of vintage computers along the wall here. And so archives of things like archives from IBM, of old service manuals and operating systems. And many of these things are things you can find on the internet. In some cases, it took me a long time to find them, so I like having them all archived in a nice format that's easy for me to locate. And so that kind of all collects together into a big chunk of data that I'd prefer not to have to rebuild. So I have that stuff backed up in a way that is pretty reliable. But those two together still isn't more than maybe a third or maybe a half of all of the total power usage. The rest of it are what I call compute servers, which are things that I actually use to do things. And so the question is, what are those things that you're going to do with all of that compute power? And there's a bunch of different things. Some of it is just experimentation. I have a Hadoop cluster and some Spark jobs that I wrote, which is primarily just to learn about the technology and be able to do Spark jobs. I had a small Cassandra cluster, which I don't have anymore. I do still have a Kafka cluster, a queuing cluster for events from house automation that I just built to kind of try that technology out. I do a lot of math stuff. If you ever watch the channel Numberphile, it's a really great YouTube channel. that always has interesting math-related either puzzles or just interesting mathematical observations. And often things they do on there have some computable element to them, meaning you can go compute something. And so I have one server that's running a calculation right now, calculating the digits of Apries constant, and I have another one doing a pi calculation, looking for what are called self-described numbers in the first 1 trillion digits of pi. And so those servers often are running what we call math jobs, so doing some math computation. I do have one box I use for FPGA synthesis. I do a lot of CPU design sort of as a hobby, and so that stuff is a little bit intensive, and so it's a job I'll farm off onto one of those servers. And then occasionally I'll come up with another cool idea of something I want to calculate, and so I'll have some compute power. Those don't always run. If I have a job I need to do, I'll fire them up and have them run their job. And that's a good way to run a home lab. And that's probably most of what I use it for. People often ask about power draw. It probably peaks at around 7 kilowatts if I have most things running, but that isn't that often. Most of the time it's around 3.5 to 4. In fact, we'll walk over in a minute and see what it's running at right now with the things that I sort of keep running. I've tried pretty hard to optimize things like powering down servers when I'm not using them and make them easy to power up. I use Ansible, so a lot of Jeff Geerling's teachings to automate deployment to things and to automate things like detection of problems. So if a drive goes bad, it'll page me or text me or email me and say, hey, you have a drive that's gone bad in an array, the hot spare's kicked in, but it'll tell me which drive bay it's in, and so I can go in and swap in a spare drive, and the drive will rebuild itself, and with little input on my part. Many people ask about how much work it is to maintain it, and actually it's not that much. I mean, setting things up takes some work, of course, but I actually don't have to go into the room that often. Almost everything is done remotely, so I can do it from anywhere. And I've tried pretty hard to keep things automated and self-scaling where possible. So, the Proxmox clusters are 4 nodes, and fully HA. So, if one were to fail for some reason, another one would pop up, and the VMs would run just fine. And that kind of keeps me from having to be in an emergency mode when something goes wrong. And so really it isn't that much maintenance. I think maybe if someone else had to come in and do maintenance, I do have a good deal of documentation written down, and some of it posted actually on the wall in there, to make it possible to figure out some things, but it's still a home environment. So, I think my wife would have a hard time figuring out what to do with it. But that's the nature of a home lab. It is a lab, and it's a place for you to explore new technologies and install things and break things, and I've broken lots of things in there. And that's really the key element behind how you learn. You install and you try. In my profession, I'm a chief technology officer, which is sort of a technology leader. And I'm a really strong believer that CTOs should be able to do the technology, the actual technology that they are responsible for. If I run data centers, I should be able to install data centers. If I build software, I should be able to build software and configure software and write software. That I think is an important skill in understanding technology, is not just the high level strategic view of it, but do I actually know how it really works? And so I put a lot of time into understanding the technologies that I use in my day job so that I actually understand them. So especially when things go wrong, you really have to jump back on only the things you already know. And so having a good deep understanding is really valuable, and I encourage anyone in technology at any level to continually be adding to the pool of things that you understand. And as soon as you get to a level, the next thing you should do is go to the next level, go deeper, understand more about what's happening under that next layer. And it will provide you a tremendous advantage when something is broken and you're trying to figure out what's happening, knowing that next level down. And that's why you have Homelabs. So I encourage anyone to build a home lab, and it could just be a single server running a hypervisor environment where you can try out different things. And with that environment, you can learn a lot. So we'll go look at the power usage. The room itself, of course, is powered off an APC symmetry UPS, but that UPS is really just there to provide the dual inline power conversion. So AC comes in and it goes to DC, then back to AC, and that makes the AC out of the UPS relatively high quality and protects you from things like brownouts or overvoltages on the incoming side. And that UPS only has a battery that lasts maybe 10 minutes at most. So if it faults and it's on UPS power, it signals into the server room, a bunch of things automatically shut down. But that whole room is also battery backed up by a house battery system, which we'll go take a look at, which is a 42 kilowatt hour lithium iron phosphate battery system that provides power to the whole house, including the server room. And I just recently added some automation so that when I'm on battery power, the house battery power, it'll signal the servers and shut down a bunch of non-essential stuff, so I don't drain the battery power or drain the battery down as quickly. So we'll go look at that and see, but hopefully that answers at least the basic question of what do you do with all of these computers? And the answer is, of course, cool stuff. So we can see the temperatures in the server room. It's 51 degrees out, so it's a great temperature for the economizer to bring in. So here you can see that the entire house is drawing 13.38 kilowatts. We're producing 7.3 from the solar, and the rest comes from the grid. And the server room itself is only at 4.3 kilowatts, so it isn't that much actually. The rest of the stuff is other things in the house that is running. And typically it'll be between 3 and 4 kilowatts most of the time. It's like it is on Sunday, so it is running a backup job right now that takes a little more power. We can take a look here. And so there's all the servers running. It's a little loud in here. That bottom left server is a backup server, which is currently running a job. And I think there's one disk array, doing a scrub right now that it does automatically. But yeah, so it's power controlled basically by turning things on and off, and I have that automated for different jobs, and that makes a big difference in the total amount of power that you use. But we will head upstairs and I'll show you the house battery backup and how that interconnects into this power. So here's a quick look at the power system sort of coming into the house. The power feed comes in over here, and it's split up into sort of a generator and non-generator side. So all the circuits in the house are allocated accordingly. Things like lights and stuff are all on that generator side, and there's a little generator switch there. But more importantly, there's the bigger box there is an in-phase Smart IQ switch, which is a box designed to disconnect from the grid and then allow you to generate an internal house grid. And it relies on a couple of things. One is batteries, and so there's 4 of these 10.2 kilowatt hour lithium iron phosphate batteries. And these batteries are, they're DC batteries, and then there are AC reverse microinverters inside of there that then produce AC and go into a little grid combiner, and then eventually feeds back into the main house grid. And of course there's 53 solar panels on the roof, and those all feed in as well. And the idea is that if you lose main power, the batteries kick in and will generate an internal grid. And that internal grid can both, of course, power the house, the server room and all of the other stuff, but also the solar can generate while you're on that internal grid. And so if it's a sunny day out, the solar can push power back into the batteries if it makes more than you're going to be using. And then if the batteries get low and there isn't enough solar, then it will auto fire up a generator to both charge the batteries and provide house power. So it's sort of a really good system for if you lose main power to keep everything running. You really don't notice it at all. The batteries kick in about 100 milliseconds, so it's pretty fast. So in general, you don't notice it at all. I do have a UPS for the server room, that APC symmetry, and that's really there to provide the double inline conversion that takes AC to DC back to AC to make really clean AC power. That way, if you have dropouts in what's coming over the grid, the power going to the server room is really reliable. But this forms sort of the backbone of what feeds into all of the house power and the server room.